Hello, my name is Lily Kandakoraengo, and I'll be presenting an analysis of a statistical machine learning task based on a dataset involving a regression technique. I plotted a scatter plot of X and Y, and it shows that it possibly indicates a nonlinear relationship. And checking for the type of the dataset, my dataset was a regression since I had a continuous numerical output. And concerning the theoretical framework, this is the mathematical technique used in statistical machine learning. There are 5 of them, and the first one is the hypothesis space, which is denoted by fx, which is the collection of all polynomial functions over degree p. And coming to the loss function, this is the formula for calculating the loss function. Then the theoretical risk, this is the formula of calculating the theoretical risk. The bias, the formula of calculating the bias is this one. And the fifth one is the empirical risk, and it's denoted by R hats. And this is the formula for calculating the empirical risk. Now coming to the estimation and the model complexity, I derived the formula of the OLS estimator, and the formula is denoted in the by f at x, which is the formula of the OLS, and it is denoted by the following matrix. And I also checked the properties of OLS. The first was the linearity in parameters, which it says that the f hat is linear in the coefficient beta, but generally nonlinear in x, especially for the polynomial regression. Then the second one is biasness, and the third one is the variance. Then I plotted a graph of the v-fold cross-validation graph, and the graphs indicate that as the polynomial increases from 1 to 8, but when it reaches at 0.8, the error stabilizes. And for the graph of cross-validation error and empirical risk, the graph shows that as the polynomial degree increases, it increases the cross-validation error, and also the empirical risk increases. Thus, the error goes on decreasing. Coming to the model comparison and evaluation, I plotted the graph of simplest, optimal, and overly complex model, and the graph shows that the optimal model was the best because it has a degree of 10 compared to the complex one with the degree 20. Since the model with the highest degree of 20 may lead to overfitting, where the model captures noise rather than the underlying trend. And also I plotted a box plot for the 3 models, which is the simplest, optimal, and overly complex. And I found that the best model was the optimal model. And I plotted also the Hanover analysis of the test errors, and I found that the errors were significant because the p-value was less than 0.05. And also I plotted a graph of the confidence and the prediction bands, which shown that it showed the fitted curve, and the fitted curve represents the predicted values of y based on the model. And also the confidence band, it shows the interval for the estimated curve. I also plotted the ROS, and I also plotted the distribution of the data sets between the spam and the non-spam messages, and it shows that the non-spam messages were higher than the spam messages. And I plotted also the graph of the ROS, and I plotted the ROS and and the distribution of the test error. And I found that healthy hair was the best model because it has a low median error rate and a narrow interquartile range, indicating a good overall performance and consistency. Thank you.